All right, boys and girls, I hate to say this is my last strategy because you never know what else I'll think of or what other strategies are out there. So I'm going to label this strategy 5, the final strategy I'm going to show you for today. So we're going to use those same exact fractions, 2/3 and 5/6. And for this strategy, we are going to make them into apples to apples again, but this time we're going to change them to decimals. And I was explaining that this is not a skill that you have to master in 4th grade. You will be introduced to it in 5th grade, but you will be using it in 6th and 7th grade math. So because we have not started talking about decimals yet, nor have we talked about dividing yet with decimals, you are going to be allowed to use a calculator for this problem. So I'm going to leave that off to the side first, and I'm going to discuss the fact that 2/3 is a fraction, but it's also a division statement. And what I mean is that when we say 2/3, what we're really saying is that 2 is being divided by 3. 2 divided by 3. And so in order to change it into a decimal, you are going to divide that problem out. Now, I know that when I divide this out using the standard algorithm, I know that there's nothing times 3 that will give me 2, so I'm going to put a 0 there. And behind every whole number is an invisible decimal. So I'm going to put a decimal there, and whatever I do to the brother, I have to do to the sister, so I'm going to put the decimal up here in my quotient as well. Now I can add 0 for days after that decimal point because it's not going to change the value of it. So now I can divide 3 into 20. Well, I know that 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, and I'm getting closer. 3 times 5 is 15, 3 times 6 is 18. Let me see, can I go one more? And 3 times 7 is 21. But that's too big because if I were to put the 21 here, I have to subtract those two amounts. I can't take 21 away from 20, but I can go back to this 18 and I can subtract 18 from 20. And the way that I got that 18 was multiplying 3, 1, 2, 3, 4, 5, 6 times. So I'm going to put that 6 up here. 6 times 3 is 18, and when I subtract, I can't take 8 away from 0. I'm going to do a standard algorithm with subtraction, or you could probably do this one in your head, but I'm going to let myself do the standard algorithm. I'm going to take 1 away from my 1's place, I'm going to add it to the 0, and now 10 take away 8 is 2, and 1 take away 1 is nothing. I am not done dividing, so I can put another 0 here until I can't divide anymore. I'm going to make that into a 20, and then I'm going to look up here again, and I see that I have 21, but I can't take 21 away from 20. I can take 18 away from 20. And as before, 1, 2, 3, 4, 5, 6, that was the 6th number I multiplied times 3, and when I subtract, I'm going to get 2 again. And what this is going to be called, because even if I add another 0, I am going to keep getting 20. So we call this a repeated decimal. Just to prove it, I'm going to go ahead and put it into my calculator. 2 divided by 3 is my division statement. 2 divided by 3, and you'll see I get that repeated decimal of 6. So I'm going to go ahead and I'm going to leave it at 66 hundredths. Now I'm going to take 5/6, and I'm going to do the same thing. So for 5/6, we're looking at the division statement of 5 divided by 6, or 5 divided by 6. And we can do the same thing again by dividing it out. I know that there's nothing times 6 that will give me 5, so I'm going to put a 0 here. Behind every whole number is an invisible decimal. Whatever I do to the brother, I do to the sister, and now I can add 0 for days behind that 5 because it will not change its value. So now I'm going to multiply by 6 until I get close to 50, but remember, I can't go over because I couldn't take 21 away from 20. I want to get as close as I can without going over. So 6 times 1 is 6, 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. 6 times 6 is 36. 6 times 7 is 42. I'm getting closer. 6 times 8 is 48. And if I went one more, 6 times 9 would get me 56, which would be way too much. So I'm going to stick with 48. That means I'm going to subtract 48 from 50. And it took me 1, 2, 3, 4, 5, 6, 7, 8 times to multiply that. So now I can subtract. Again, I can use my standard algorithm for subtraction if I need to. So I'm going to borrow 1 here and add it here. 10 take away 8 is 2. I'm not done dividing, so I'm going to put a 0 here and I'm going to bring it down. Now I'm going to divide 6 into 20. So how close can I get here? Well, I see a 24, but that's too big. I can't take 24 away from 20. So I'm going to stick with 18. That means I'm going to take 18 away from 20, and I used 1, 2, 3 times to multiply that. 3 times 6 is 18. 20 take away 18 will give me 2. And then look at what happens again. If I keep adding that 0 there, I'm going to again keep getting 20. So I'm going to have a repeated decimal of 3. And I can prove that by going to my calculator, typing this in as a division statement. 5 divided by 6 equals 8 with a repeated 3. So now what I'm going to do is I'm going to compare my two decimal amounts. I had 2/3, which I changed into 66 hundredths as a repeated decimal. And then I had 5/6, which I changed into 83 hundredths as a repeated decimal. And just like comparing numbers, if they were whole numbers, I start with the ones place. That doesn't help because I have 2 zeros. I go to my tenths place and I see a 6/10 and an 8/10. That means I have 6 dimes here, or 60 cents, and I have 8 dimes here, or 80 cents. That means that that number is greater, which means that this fraction is greater. So 5/6 again proved 5 times in 5 different ways 2/3 is less than 5/6. Again, I don't expect mastery with this skill. You can use a calculator, you can explore, but this is not a 4th grade skill.